Good morning, everyone. Our project is titled Image Generator App. It focuses on creating high quality AI generated images from text prompts using Stable Diffusion, and our team members are Sridhabadram Raju and myself and Funny. So here comes to the outline. We have title, introduction, aim, motivation, objectives, tools and algorithms, methodology, environment setup, model setup and integration, interface design, testing evaluation, code, and the conclusion. So here we come to the introduction. AI generative has transformed digitally creative. Instead of coding models from scratch, we use Stable Diffusion Web UI, a popular open source tool that turns a text into images. Our focus was on deploying it locally, experimenting with different prompts, and understanding how parameters affect the output. So our aim is to successfully deploy the Stable Diffusion Web UI locally to generate, customize, and analyze AI-driven imagery based on test prompts. Uh, we have motivated by three things: understanding diffusion models, gaining hands-on experience with AI tools, and improvement efficiency through fast experimentation. And our motivation is to focus on technology to practically explore the master and the stage of the art diffusion model architecture and its powerfully application in text to image synthesis. Focus on practical skills to gain hands on expertise and local deployment of professional grade AI tool and development advanced prompt engineering and parameter using tuning skills. Focus on efficiency impact to leverage the streamlined stable diffusion web UI installation method to efficiency maximize time spent on creative experimentation and output analysis. So, Aaron, start.
Objectives are five main objectives to complete the five setups. Generate multiple images, analyze parameter impact, compare model versions like HD 1.5 and HD XL, and documents all results and observations. Compile a clear report that includes documentation of the setups, screenshots and generated reals and analysis of experimented parameters. Tools and algorithms and methodology. We used Python, PyTorch, and Hugging Face diffusers. Stable diffusion works by gradually removing noise from random pixels to form an image guided by our text. The CLIP encoder translates our prompt into numbers the model understands. Our methodology has 5 steps: environmental setup, model setup, implementation, UI design, and testing.
Methodology and diagram. Uh, Environmental setup, install Python libraries and configure local runtime. The model setup, download the load stable diffusion models from Hugging Face. Implementation, connect text input to image generating pipeline. Interface design, build UI with Gradio and Streamlit. Testing and evaluation, generate sample images and tune parameters. These are the 5 steps like data model selection, environmental setup, implementation, 4 interface development, 5 testing and evaluation. You can see the steps below. Objective 1, environmental setup. To install the configure and all necessary dependencies for running stable diffusions locally. And steps are install Python 3.10 plus required packages, talk diffusers, transformers, accelerate Gradio. Set up CUDA if GPU available for faster image generation. Verify installation by importing all libraries and checking model compatibility. Ensure all the 8 GB RAM and 10 to 15 GB disk space for model storage.
Model setup and integration. To download and integrate this stable diffusion model for local image generation, steps are: create a Hugging Face account and accept model license. Download the stable diffusion checkpoint, example HD 1.5 or HD XL. Local model into Python using the diffusion pipeline API. Configure model parameters such as inference steps, guidance scale, seed value, test pipeline with a sample test prompt.
Objective 3 is interface design. To build user interface for image generator app, and steps are use Gradient Streamlit to develop the interactive web-based interface. Create text inputs fields for user prompts and buttons for image generation. Connect the input prompt to the Stable Diffusion pipeline to produce images. Display the generated images within the same interflow window. Add additional controls, guidance scale slider, sampling step selector. Test the interface locally in the browser to ensure the smooth performance.
Objective for testing and evaluation. To test and evaluate the model performance. Steps. Input various steps prompts. Example, a futuristic city at sunset. A robot painting. Evaluate results based on image clarity, prompt accuracy, generation time. Compare CPU versus GPU performance. Tune parameters like inference, steps, and guidance scale for better quality. Record outputs and analyze the impact of parameter changes on results. Validate that the app runs fully offline without internet dependence.
We run in the Google Colab. Now I'll explain the code line by line. First, we import the required libraries. Open the Google Colab, click on runtime in the menu, change the runtime type, choose GPU and select T4 from the drop down. So, I'll explain the code now. From diffusers import Stable Diffusion pipeline. Diffusers gives the pre-trained text to images models. Talk is the PyTalk framework for running the model efficiency. These are the core foundations that make AI generation possible. From here, next we load the model using Python. Pipe is equal to Stable Diffusion pipeline dot from underline pre-trained model ID talk dtype talk float 16. From pre-trained loads all the model weights and the configuration from Hugging Face. We choose version 1.5 because it gives the high quality and constant results. Later we can replace it with SDXL or other versions of the comparison. We use GPU for speed. To make generation faster, we move to GPU. To CUDA. This enables the use of CUDA, meaning all the heavy now using GPU for speed. To make generation faster, we move to the model to the GPU. This enables the use of CUDA, meaning all heavy computations are handled by GPU. With GPU, one image takes 8 to 10 seconds. On CPU, it can take over a minute. Writing the text prompt. Now we define our prompt. Prompt is as we given kids eating the ice cream. This text encoded by model using CLIP, which converts the words into numerical vectors that model understands. We can experiment with creative by changing a style. For example, a painting of a cyberpunk city or the medical castle in a fog. This is where prompt engineering becomes important. Small world changes give completely different outputs. Generating images. Next, we generate the image using the the prompt we use here is image is equal to pipe prompt images image.save output.png. Here what's happened is internally the model starts from pure noise, a random image. It repeatedly refines the noise in a certain number of interface steps. Each steps bring the image closer to what the test describes. Finally, the output image is saved as output.png. We can adjust sampling steps and CNG scale to balance between creativity and accuracy. Understanding the key parameters. Two of the most important parameters are CFG scale, this controls how strictly the model follows our text. The highest CFG scale, around 10 to 12, gives more accurate but sometimes less creative image. A lower value, 6 to 7, gives more artistic imagination outputs. Sampling steps, this decides how many refinement steps the model takes. More steps mean higher quality but longer generation times. Around 50 to 30 to 40 steps usually gives the best balance. Running in the Google Colab. We ran this in the Google Colab, so we also implement this in the Google Colab for users without any powerful local setup steps. Open the notebook, go to runtime, change the runtime to GPU T4, run the same code. This way, anyone can test the image generated using cloud GPUs for free. Interface integration. Finally, we connect to the model to an interface using radio. This gives a local web app where users can type prompts, generate images, and download them. Interface makes our project interactive, user friendly. To sum up, the core integrates AI, art, and engineering beautifully. We learned how stable diffusion works, how prompt tuning changes results. To sum up, the code integrates AI, art, and engineering beautifully. We learn how stable diffusion works, how prompt tuning changes results, and how to deploy it locally and on the cloud. Overall, this project gives us the hand-on experience with real full generative AI applications and strengthen the bond of our coding and analytics skills. Come to the conclusion. This project successfully demonstrates the deployment, the operation of the state of the art text to image generation system using stable diffusion. Through hands-on experimentation, we explored the effects and the difference of the parameters such as CFG scale, sampling steps, and the model checkpoints on image fidelity and style. The implementation highlights how generative AI can be efficiently utilized for creative content generation both locally and in cloud environment like Google Colab. Overall, this project enhanced our understanding and AI-driven creativity, deep learning pipelines, and the practical challenges of model deployment, bridging technical knowledge with the real-world artistic innovation. And this is our AI generative app code. You can use this prompt and get your images done. Thank you.